Hello everyone and welcome to my channel. Today's topic is front-end system design for slider. Let's talk about what slider is. A slider is a tool on a website that lets users pick a value within a certain range. I thought about whether to use a basic slider that comes with the web browsers or to make a custom one. I've decided it will be more exciting to design a custom slider. Before we dive in, let's categorize sliders into three types: video slider, histogram slider, and just simple slider. Creating a universal design that fits all these types will be challenging. Plus, I believe maintaining such a slider would not be as simple, so we will focus on designing just a simple slider. Our plan is on the screen, so let's start from the functional requirements. In the first requirement is immediate interaction. The slider responds right away when the user moves the thumb, showing changes at once. The next one is value limits. The minimum and maximum values are clearly marked on the slider so users know the range. Next, vertical layout. The slider can be placed vertically or horizontally. The next one is step support. The step attribute specifies the interval between numbers. Snap to steps. The slider's thumb moves to the closest valid number by itself to help users pick exact values. Adaptability for direction. Sliders should work both ways, left to right and right to left, for different reading styles. The next one is thumb size. Make sure the slider's thumb is big enough to click easily. The next one is hover indication. When you hover over the thumb or the thread of the slider, the cursor should change to show it can be moved. And disabled state handling. If the slider is turned off, it should stay put and not react to clicks or keyboard. Now let's talk about non-functional requirements. Let's add a new block and add our requirements here. The first one is responsive design. The slider must work well on all devices screens. Cross-browser compatibility. The slider must work on different web browsers. The next one is accessible use. The slider can be used with assistive tag and by keyboard for all users. And the last one is fast response. The slider must work fast without any wait when users interact with it. Now let's consider our UI. Let's create a new block for UI and add a few inputs here. Let's add just simple input with steps and value, and let's create a new one but with two thumbs. Okay, let's start what thread is. The long horizontal line represents the slider's thread. It's divided into two sections: the active section, which is filled in with color to the left on the thumb, and the inactive section, which is plain and extends to the right of the thumb, up to the maximum value. The next one is thumb. The thumb is shown as a small circle on the thread. This is the part of the slider that users can click or drag to adjust the value. The next one is tick marks. There are small lines along the active part of the thread, called tick marks, which help users understand the increments in the slider's range. The next one is value indicator. Above the active thread and thumb, there is a value indicator shaped like a speech bubble with a point directed towards the thumb. It displays the current value, which in this case is 60. And the last one is min and max values. On the left and right ends of the thread, we see the labels min value and max value, so indicating the range of the sliders. Also, min and max values can be used within the another input, where we use min and max values as the thumbs. Now, when we created our UI, let's create interface for our component. I will add interface slider component options with no values. Now, let's start adding our values one by one, and the first one is ID. ID has type string, and it uses to reference the slider elements with label. The next one is name with string type. Name used to reference elements in JavaScript. The next one is type. It can be single or min-max. Slider can have one or two sums. So when we use single, it has one sum, and when we use min-max, we use two sums. The next one is value. Value is optional number required for single sum slider. So when we have type single, it's required. But when we use min-max, then it's not required anymore. The next field is min value, which is optional number as well. Min value and max value, which will be the next one, can be used for one sum slider as well, but they're required for two sum slider. So it means that min and max values can be used with both single and min max types. But they have different responsibilities. With single type, they show min and max values as labels. With min-max type, they work as sums. The next optional field is step, which has number type. It defines the steps in which the slider can move. When we have single type and want to have min and max values for accessibility, for example, but don't want to show them, we can use should show min and max values. It can be optional field which has boolean type, so it just shows min and max values on the screen. The next one is value position. It has type value position. It can be on thumb, left, right, etc. It's when the value should be shown. The next field is vertical, which is optional and has boolean type, if the slider should be vertical or horizontal. The next one is should snap, which is also optional and boolean value. It helps users to use steps. It will move to the lowest step upon clicking. So when we click between two steps, it should go to the lowest step. The next one is disabled value, which is optional and boolean. It defines if the slider is disabled. Next one is sum. It's optional function. This is a function that returns a custom sum element. It receives values, which is also optional, and returns HTML element. The next one is thread style, which is optional and has CSS properties type. It just sets thread styles to customize the thread. The same, but for the step styles as well. It's just styles to customize steps. Cursor style on active, it's our optional and next field, which has cursor style type. It should receive some CSS styles to apply when the thumb is active, for example on hover or focus. And let's add our event allbacks. The first one is on change. It's allback after value changes. It receives value and just return nothing. And two more allbacks. The first one is on start. It's allback when sliding starts, and on end. It's allback after sliding ends. They both return nothing. Now let's add a new topic and discuss how can we optimize our component. And the first one is media queries. Use media queries to change the size of the slider thread and thumb based on the screen size. On smaller screens, you might want to make the thumb bigger for easier interaction. So, to make responsive slider, we need to use CSS. The next one is CSS supports. It helps us to specify CSS declarations that depend on a browser's support for CSS features. So using supports, we can write that CSS which will be appropriate for a browser. The supports rule in CSS can be particularly useful for optimizing a slider by ensuring that you use the most efficient and appropriate styles based on the browser capabilities. It doesn't directly optimize the performance of the slider, but rather allows you to write CSS that is as performant as possible within the constraints of each browser's support for modern CSS features. The next requirement is throttling. Throttling is a good choice for animating a slider's some because it ensures that the animation updates happen at a consistent, controlled rate. This prevents the animation from becoming choppy and keeps the interface responsive without overloading the browser with too many updates. Minifying on press our solution is our next requirement. Minifying involves removing all the white space in the file that is only there for human readability once the code is put into production. Now the main question: how will we remove a thumb element? Using transform, translate, or animated left property. Let's consider advantages and disadvantages of each approach. The first one will be position absolute and left property, and here are advantages. Simplicity. It's straightforward to understand and implement, especially for beginners. Fine control offers pixel perfect position, making it easy to place the element precisely where you want. Now let's consider disadvantages. From disadvantages we can add performance. Animating the left property can lead to less efficient animations. It can cause reflows and repaints because the browser needs to regulate layout, which can be particularly taxing on low-powered devices. The next one, smoothness. While widely supported, using left for animation isn't always the best choice for achieving smooth transitions across all devices. Now let's consider animation using transform translate. This approach has such advantages. Performance, our first advantage. Transform translate is more performant than animating left. This is because changes to transforms are handled by the GPU, which can manage these animations more efficiently, leading to smoother animations, even on devices with low computing power. Smoothness offers smoother animations as it doesn't trigger layout or repaint operations. Flexibility. Translate and move the element in both the X and Y directions in a single line of code, offering more flexibility with less code. At the same time, it has such disadvantages. Complexity in layout. Since transformed elements don't affect the document flow, the space the element would normally take up. Using translate might require additional considerations for layout design, especially in complex layouts. Subpixel rendering. At times, translating by non-integer pixel values can result in blurry edges on some screens due to how browsers handle subpixel rendering. However, this can be mitigated with proper scaling or by ensuring pixel values are rounded. Use CSS iframe animations or CSS transitions if it's all possible. The browser can optimize painting and compositing big time here and there. Using 2D transforms instead of absolute position will typically provide better FPS by way of a smaller paint times and smoother animation. Good, now let's talk about accessibility. By the way, do you care about the accessibility of your project? Leave answers under the video. Our first requirement is keyboard support. Users should be able to change the value using keyboard only. All functionality must be operable using keyboard. The next one is contrast. Our input should have enough contrast to be visible. Then input purpose. Inputs should have their purpose ID for user assistance. The next one is orientation. Content must work in any orientation, portrait or landscape. Orientation, which we discussed before, it's more about design rather than accessibility. But even if you have vertical custom input, it should have area orientation set to vertical. The default value of area orientation for a slider is a horizontal, so don't forget to update it. The next one is animation from interactions. Motion animation triggered by interaction can be disabled. Input should work well without animation. Errors identification. Our next requirement. Errors are identified and described in test. The next one is focus visible. Abort focus indicator is visible on user interfaces, so please don't hide it. And the last one is screen reader friendly. It should announce what name and type of the input, what is mean and max values and current value. Everything should be screen reader friendly. That's all for today's video. Let me know which topic will be interested for you in the future in the comments. Thank you and see you next time. Bye.